In this video, we are going to look at question 42 from the specimen paper.
We have just arrived on a newly discovered planet, and first thing we see is a local inhabitant of sorts playing with a ball. And that's a great opportunity for us to learn something about this new planet. In particular, we are on a mission to find out which of these combinations of height reached by the ball and the gravitational acceleration on that planet, which is the property of the planet in question, is a possible combination of the two quantities, considering that the ball is thrown into the air, or, well, there's no atmosphere, so thrown into the space with a speed of 20 meters per second. And as usual with any projectiles and anything being thrown into the air, we want to use our conservation of energy. So the kinetic energy at the bottom must equal the gravitational potential energy at the top of the trajectory. Half mv squared, the kinetic energy, must be mgh. And the masses cancel, which is good for us, because the mass is an unknown quantity. And we see that half v squared must equal gph. So when we plug in 20 meters per second for the speed, we get that the product of the gravitational acceleration on this planet and the height reached by the object must be 200 in some standard SI units, which we are using throughout. But only one of these options given here does give a product of 200. Only B does. So from these options, we can see that it must be that the gravitational acceleration is 5 meters per second actually. It's supposed to be a 2 here. The height reached will be 40 meters, and B is the correct answer.